NASA has just confirmed that its Voyager 1 probe, the most distant human-made object in the universe, is once again sending usable data back to Earth. Currently, it's transmitting what's known as health and engineering data, essentially confirming that the spacecraft's systems are still operational. But Voyager 1, and its twin Voyager 2, have been part of some of humanity's most ambitious space missions. The data they are returning from the far reaches of our solar system could dramatically alter our understanding of the cosmos, with potential implications that stretch far beyond space exploration. One of the most shocking discoveries from Voyager 1 is a completely new magnetic field, one that nobody anticipated. This magnetic force is far more complex and powerful than what scientists had predicted, and it may require us to completely rethink how we understand the interplanetary environment. Even though Voyager 1 passed beyond the influence of the Sun's magnetic field and entered interstellar space, the spacecraft has encountered a stronger and more intricate magnetic force than expected. This unexpected finding could have profound effects not just on our scientific knowledge, but also on the future of space travel, how we protect Earth from cosmic radiation, and even how we perceive the universe itself. This new magnetic field is more than just an interesting anomaly, its potential consequences could reshape humanity's approach to space exploration. If this magnetic phenomenon plays a crucial role in deep space, it might offer us new insights into how we protect astronauts during long-duration missions and even inform space colonization strategies. However, there's a darker side to this discovery. If this magnetic field is part of a larger, unidentified force that has yet to be recognized, it could pose unforeseen risks to both future space missions and life on Earth. The timing of this discovery is critical, especially as private companies like SpaceX are accelerating efforts to establish a human presence beyond Earth. The implications of this new information could fundamentally alter the way we think about space technology and safety. For years, Voyager has been humanity's eyes on the furthest reaches of space, and the recent discoveries at the edge of our solar system have forced scientists to reconsider their understanding of the cosmos. In 2012, Voyager 1 crossed into interstellar space, more than 23 billion kilometers from Earth, beyond the boundary known as the heliopause, where the Sun's solar wind no longer dominates. However, instead of encountering the serene emptiness scientists had anticipated, Voyager found a dynamic environment filled with unexpected phenomena that could permanently change the course of space exploration. Perhaps the most startling finding has been the discovery of cosmic rays, high-energy particles usually associated with the catastrophic events of black holes and supernovae. Scientists had long assumed that the solar system acted as a protective shield, blocking out most cosmic radiation. But as Voyager passed through the heliopause, its detectors picked up a sharp increase in cosmic ray intensity, revealing that this shield wasn't working as expected. This surge in cosmic rays is not a small, isolated event, it's a significant spike, one for which scientists were completely unprepared. This discovery raises critical questions about humanity's readiness to face the harsh realities of space once we venture beyond the protective reach of our Sun. Are future interstellar missions at risk from these unanticipated radiation levels, especially for astronauts who will travel far beyond Earth's orbit? We have barely scratched the surface of what lies beyond the Sun's influence, and these cosmic rays might be a sign of something far more dangerous lurking in the interstellar medium. NASA, and other space agencies are intensively studying these findings, but the issue is no longer a purely theoretical one. With companies like SpaceX planning long-term missions to Mars and beyond, we're getting closer to a reality where humans will spend extended periods in space. And now, we must confront threats we never anticipated, unseen forces in the deep unknown that could be far more dangerous than we ever imagined. These findings have forced scientists to reevaluate everything they thought they knew about the solar system's boundaries. For many years, astronomers believed that the heliopause would be a well-defined limit, marking a clear division between our solar system and interstellar space. But the data from Voyager reveals a much more complicated picture. The spacecraft has detected strange fluctuations in both magnetic fields and plasma waves, which conflict with current models of how the solar wind should behave at the boundary. These irregularities point to factors that remain a mystery and could have significant consequences for both Earth's safety and future space travel. NASA's role in unraveling these mysteries is more important than ever. With its unparalleled expertise in space exploration, cutting-edge data-gathering capabilities, and advanced modeling tools, NASA is uniquely equipped to turn these surprising discoveries into useful information. The agency is already preparing follow-up missions to monitor the interstellar medium, and gain more precise measurements of these magnetic fluctuations, hoping to shed light on what's really happening at the edge of our solar system. As we look to the future, NASA is already planning groundbreaking missions that will venture even further into the unknown. However, these unknown magnetic forces present a major obstacle. The findings from Voyager suggest that future space missions could be impacted by these forces, potentially jeopardizing the safety of astronauts traveling beyond the solar system's protective bubble. If these forces are as powerful and erratic as they appear, they could pose a serious threat to space travelers and the technology we rely on. Even more unsettling is the possibility that the heliosphere's irregularities could be a sign of something much more significant, a hidden force that could affect not only space exploration but the entire solar system. These discoveries challenge everything we thought we knew about space and how the solar wind interacts with the interstellar medium. The inconsistencies in Voyager's data point to a complex, previously unidentified interaction between cosmic dust, solar wind, and magnetic forces that could have far-reaching consequences for humanity's future in space. The stakes are high, not just for scientists but for all of humanity. These new discoveries force us to reconsider how vulnerable our technology and astronauts might be to forces that were previously unknown. As private and governmental space programs continue to push the boundaries of human exploration, we must prepare for the unexpected. Could these forces be a threat we are not ready for, or could they unlock new opportunities in space exploration, such as new propulsion methods or better ways to shield astronauts from radiation and cosmic dust? Voyager's latest findings are a game changer for our understanding of space, but they also present real risks. The increase in cosmic ray intensity at the solar system's edge is a clear indication that our understanding of the heliosphere's protective role is flawed. This issue doesn't only affect space travelers, it could also have an impact on life on Earth, especially if cosmic radiation were to penetrate our protective bubble more deeply, or even reach Earth itself. The implications of this discovery could alter the course of space travel, technology development, and even our ability to survive in space in the future. There's one more challenge on the horizon, though. Voyager's power supply is expected to run out by 2025, and as its energy reserves dwindle, the ability to transmit vital data back to Earth will be severely limited. If Voyager's communication systems fail, scientists will lose a crucial source of information at a critical moment, which could delay or even derail the next phase of our exploration. Despite these challenges, Voyager's journey has already exceeded expectations. Its detailed data on the interstellar medium has provided new insights into the unexplored regions of space. But as Voyager moves deeper into uncharted space, it continues to present more questions than answers. The anomalies it's detecting, changing magnetic fields and unusual radiation patterns, suggest that there is far more to interstellar space than we ever imagined. Is Voyager encountering unknown interstellar objects, or is it picking up signals from entirely new types of cosmic bodies that our existing models can't detect? If these discoveries are confirmed, they could revolutionize our understanding of the universe's fundamental structure. What else might be out there, lurking in the vastness of space? As we continue to study the data returned by Voyager, the stakes have never been higher. The answers Voyager provides in the coming years could shape the future of space exploration and technology. Will we discover a new era of cosmic discovery, or will we encounter an unseen danger that threatens humanity's future in space? The next few years will be critical in determining how we prepare for what lies ahead.